Good morning, students. Today we are going to continue the topic that is carbon and its compounds. Yesterday we have discussed about the butane and isobutane, pentane and isopentane. One more was neopentane. Today we'll go for the hexane. Before going for this hexane, because these all are the topics of isomers, that is chain isomers. Now we'll go for the next part, that is hexane. Before going for the hexane, you have to go for some more additional information. Then we'll go for the hexane. The word is alkyl, ALKYL. Now the word is not alkane, not alkene, not alkyne. It is alkyl, alkyl group. These are alkyl group. Which are those? What difference is there between the alkane and alkyl? A minute difference is there. Alkane is a full compound, alkyl is a functional group. It also acts as a functional group and it is used as a prefix. Alkyl group is used as a prefix. Alkyl group. Which are the chemicals will come in the alkyl group? The group of alkane, the group of alkane only. The group of alkane will be available as a alkyl. Bit difference is there. What the difference is there? A difference of hydrogen. One hydrogen will be minimized or reduced from the alkane, will become alkyl group. For example, I'll take the both example, alkane and alkyl. See here, from A and E, from A and E, they have removed A and E and they added the YL. Removed A and E, added YL. From alkane to the group has become alkyl. Alkane is a full-fledged chemical. Alkyl is a functional group. I repeat, alkyl is a functional group. Alkane, the first chemical is methane. The first chemical of alkane is methane. Methane. The first chemical of alkyl, the first functional group, we have to use the word functional group of alkyl is, automatically the word has been changed. From methane, METH will be available. METH will be available. Now instead of ANA, it becomes YL. Meth, both the point, the meth is available. Here also meth is there. Meth, but instead of AN, it has become YL. This is a change. And what change in the chemical formula? The chemical formula change. The formula of alkane is CH4. The formula of chemical is CH4, and for the methyl, the formula is CH3. The chemical is CH3. One hydrogen has been reduced. One hydrogen has been reduced and it is considered as an S methyl group. If you go with the methyl group, it is a functional group. Methane is a hydrocarbon and methyl is a functional group of hydrocarbon. You are going to learn that in the next topic. Methyl. Next, after methyl, we are having the ethyl. Ethyl. Ethyl, once again the same is there. ETH, sorry, First comes the ethane, ethane, and here is ethyl. Here is ethyl. S A N E. Ane, it is replaced by YL. Ane is replaced by YL. What is the formula of ethane? The formula of ethane is C, C2H6. The formula of ethyl is C2H5. One hydrogen will be removed. C2H5. Next, the third chemical is propyl, propane and propyl. Propane is the third chemical of alkane group, and for the alkyl group, the propyl is the third chemical. Propyl is the third chemical. Instead of once again any while has been added. Instead of any while has been added, and one hydrogen is removed. The formula of propane is C3H8. The formula of propyl is C3H7. Now, but here we will mention here this dash. Why this dash system? But it is a bond. Means it is incomplete. It is complete actually. It is a complete chemical. It is an incomplete chemical because it is a functional group and it has to be attached with a hydrocarbon only. Once again, I repeat, this chemical, methane is there, ethane is there, propane is there. These are complete chemicals. These are compounds. These are not compounds. These are functional group. These chemicals they have to attach with one of the hydrocarbon group only. So only there is a bond. Means they have to attach. They have to attach with the some of the chemicals. We will learn that topic in the next class. We'll see it how the bonding is. Here is the CH3. Now CH3 is directly there. C2H5 can be written in two ways. C2H5 directly you can write it, or one more is there. CH2 CH3. Means this carbon is having two bonds with both the sides and two hydrogens, and all of you know that each hydrogen is having one bond. Now this carbon is having one bond with this carbon and three bonds with the hydrogen. Once again same only. C1, C2 is here, C1 and 2, hydrogens 5, 2 and 3, 5 are there. The same with the propyl also. You can write propyl also in the same way. But number of carbon is 3. 1, 2, 3. Now number of hydrogen 7. At last, because there is a single bond between all the carbons, now I have to write only the hydrogens. This carbon is having two bonds, hydrogen is 2. This carbon is having two bonds, hydrogen is 2. This carbon is having one bond, hydrogen is 3. Okay, this is about the group of alkyl. One more chemical is there that is called as the fourth chemical, butane. Usually they will ask about this only three: methyl, ethyl, propyl, or butyl groups. Remaining are pentyl, hexyl, heptyl. Usually it will not be there. It will be there if the number of carbon, the main carbon chain, if it is more than 20. for 30 or 40. But number of carbon usually it will be 10 or 15 will be there. At that time, these will be added. Okay, those things we'll going to learn in the at last. We'll go for the nomenclature of carbon compounds. Nomenclature: how to name a chemical. Maybe you studied about the word called as binomial nomenclature in the class 9. That is in the diversity in living organisms. The same way, diversity in living organisms, you are having that naming of an animal or a naming of a plant or naming of microorganisms. In the same way, when the naming of these chemicals are also there. Nomenclature is a thing, but naming of these chemicals, that thing we are going to learn in the next classes. Yes, because when you learn this all the rules, automatically half part you are going to learn here only that in the naming or nomenclature of carbon compounds, you are going to learn those remaining points. Okay, here methane, ethane, and propane is completed. Now the butane is remain. The fourth chemical usually four will be there. I'll write butane in this right part. Butane and butyl. Difference, I'm showing the difference of main compound and difference with the alkyl group. Alkane. Alkane is a complete chemical. Alkyl is a functional group and it is used as a prefix. Okay. Next, I'll go with the last chemical, butane. I think so all of you know about the butane. The formula of butane. The formula of butane is C4H10. It is butane. If you remove one hydrogen from the butane, it becomes butyl. Butyl, butyl is C4H9. Butyl is C4H9 and along with the bond means it should be bonded because it is a functional group. How there is a functional group like the prefix called as halides, fluoro, chloro, bromo, and iodo. Even the butyl group is also a functional group. It is also a functional group. Okay, now we'll complete this butyl group C4H9. C4H9, how to write it? In this way, we are having four carbons: one, two, three, four. Butyl group. Now we'll go with the number of hydrogens. This carbon is having two bonds in both the sides. Now it requires two more bonds. It will complete with the hydrogen. This carbon is having two bonds, two more bonds, that is with the hydrogen. This carbon is also having two bonds. Now it is with the hydrogen. This carbon is having one bond. It requires three hydrogens. Means CH3 is at the last, starts with the CH2, 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 CH3. Yes, it is the group of butyl. Usually we will ask only, there will be methyl group, ethyl group, propyl group, and butyl group. I show the difference with the alkane because alkane is a complete chemical, alkyl is a incomplete chemical, but it is actually a functional group. It is the functional group. Okay, this is one more functional group what I have learned today. Now, after completing this, we'll go for the chemical number. We'll go for the second part actually. Actually, there is a word called as hexane. That hexane, we can go with the six chemicals actually. Five different, not six, five different structures of hexane can be shown here in your books also. You can prepare the five different structures of hexane only. We have shown two structures of butane, three structures of pentane, but we can show five structures of hexane. Butane and isobutane, two structures. Pentane, isopentane, neopentane. Hexane names will be a bit different. There you can learn this methyl, ethyl, all the groups. Even you have to show the positions also. Position of chemicals also have to show it here. I'll show it now here. Let's go with the hexane. That is the isomer. Once again, the isomers. Yes, yesterday I discussed about the two structures of butane, three structures of pentane. And just now I told about it. Now we'll go with the hexane. Hexane, five structures of hexane. Hexane. The formula of hexane is C6H14. C6H14 is the formula of hexane. Number of carbon are 6. Number of carbon are 6. If you have time, have the book compulsory while because these topics are most important and you have to copy it and you have to practice it compulsory because the question of the butane, pentane, and hexane it has been appeared in the board exam repeatedly. After every alternative year, this question have been repeated in the board exam. So please go through these all things. Even they ask the structure of hexane, unfortunately, one of the time. Yes, the structure of hexane. Number of carbon should be 6. Okay, number of carbon are 6. Yes, it is ANE single bond. Single bond is there. Now all of them. Now we will go for the remaining hydrogens. Okay. Okay. C6H14. It is a normal hexane. Now remaining are isohexanes in the different structures. Isohexanes are draw that side. Okay. Isohexane. Now it is the first structure of hexane. I'll go for the second structure of hexane. It is number of carbons are 6. 1. Number of carbons are 6. 1, 2, 3, 4, 5, 6. Number of carbons are 6. Hydrogens are 14. Now already there is a straight chain. Now I will branch at the center. The center center carbon. Branch are the center carbon. Yes, five straight chains are there. One is branched. One is branched. Okay, this is about the 5 plus 1. 6 carbons are there. This is the second structure. Okay, second structure is here. I'll show the hydrogens also. Yes, the second structure is ready. We'll go for the third structure of. Now, what is this third structure? One structure, two structures are over. The third structure of hexane. This number of carbon once again. Number of carbon 1, 2, 3, 4, 5. Five are straight. Now what happens here? Even here we get the positional isomer. Positional isomer, because these are having different names. I'll tell you the names of these chemicals. First I'll write the structure of it, then I'll show the name of the chemicals. Okay, here number of carbons are 5 at a state, but here now if you see this carbon, it is at the third carbon for the main chain. Now, which is the main chain? 1, 2, 3, 4, 5. These five carbons are straight. This is branched. This is only branched. It is a different name. These five. This carbon portion is for the 1, 2, 3, 4, 5. Means for the third carbon. Third carbon, this carbon is attached. Here, for the second carbon, will attach it. Which is the second carbon? Which side this attachment will be there now, or the additional functional group will be there now. That side is called as the second carbon. I can show here also. I can show here also, because 1, 2, 3, 4, 5. If I show it here, if I show it in this place, if you count 1, 2, 3, 4, 5, this carbon is near to the this side carbon. So this is called as second carbon. 1, 2, 3, 4, 5. Because this attached carbon is near to the, or the function group carbon is near to the this side carbon. So this is called as first carbon, second carbon, third carbon, fourth carbon, fifth carbon. Now if I rub it everything once again, I'll write it once again. Once again, 1, 2, 3, 4, 5. I'll write carbon attached here. Yes, not this side, I'll write that side. Now, this carbon, that is attached carbon, is near to the this carbon. So, this is first carbon. 1, 2, 3, 4, 5. Wherever it is near to that now, those are called as nearest carbon. So, it is called as 2-methyl group. 2-methyl, because Nearby carbon is here. I'll tell you those all points just to have some time that will be understood in some time. So I'll show one side and then on the side. One, two, three, four, five. Five carbons are there. Now I'll show it. I'll show it at the right side only. Six one is here. Okay. Now this carbon is the first carbon. This is second carbon, third carbon, fourth carbon, fifth carbon. Now I'll show the bonds. Okay. Now remaining bonds also show it here. This carbon is having only one attachment. One bond, two, three, four. This carbon has one bond, two, three, four. This carbon has two bonds, three, four. This carbon has two bonds, three, four. This carbon is having one, two, three bonds are there, four carbons. This carbon has one bond, two, three, four. Now all the carbons are having four bonds. Now I'll show the all the hydrogens. Yes, here is the third structure. First structure, second structure, third structure, and it is attached to the second carbon actually it is. Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. But totally in this whole chemical, we are having six carbons, and in this group also we are having one, two, three, four, five, six carbons are there. Six carbon, 14 hydrogen, six carbon, 14 hydrogen, six carbon, 14 hydrogen. So all are considered as hexane, but names are different. What names are there? Along with the names, you are also going to learn the topic called as positional isomer. These are chain isomer only. Along with the chain isomer, you are going to learn positional isomer. Okay, what is that? Five carbons are there, but this attached carbon, this group is at the third carbon. This group is called as this CH3 portion is the norm. This CH3 portion, okay. One is here, one more is here. This carbon or this CH3 has what is CH3? CH3 means it was called because it is additional from the main group. It is the main chain, it is the branch. This part is branch. This is the main chain and this is branch. Main chain and branch chain. Main chain and it is branch. What is branch? CH3 is branch. Only CH3. What is CH3? A single bond with the CH3 is called as methyl group. A single bond with the CH3 is called as a methyl group because it is separately attached with this main carbon group. So it is called, which portion is there at the 1, 2, 3, 4, 5 carbon or 1, 2, 3, 4, 5 carbon. So it is called as 3 methyl 3 methyl because this CH3 is attached with the third carbon. So it is 3 dash this CH3 attached with this separately for the main carbon chain. So it is called as methyl. Now how many main carbon are remained? 1, 2, 3, 4, 5. Now remaining 5 main carbon are remained. So it is, and all are single bond. So it is pentane. 3-methyl pentane. I repeat the chemical once again because it is bit difficult for you, because this is a question which was already asked in the board examination. So 5 are straight chain, 1 is branched. I repeat, 5 are straight chain. If you go here, 1, 2, 3, 4, 5. 5 are straight chain, 1 is branched. This carbon is branched. 5 are at the straight chain, or it is also called as parent chain. Parent chain. Parent chain, and this is branch one. 5 are main chain, that is parent chain, also can call it as, it is called as parent chain, and this is called as functional group now. Now CH3 is considered as functional group. So this first part I mentioned here, I mentioned the methyl group, and this methyl is placed at the third position of the carbon. Third position of the carbon is called as 3-methyl. And the in the parent chain, we are having 5 main carbons with all single bonds. 5 main carbons with the single bonds, so it is called as 3-methyl pentane. 3-methyl pentane. Now we are having the one more chemical. You'll get the idea now. Usually, now it is considered as 2-methyl pentane, because this group CH3 group is attached to the second carbon, because this CH3 group is near to this carbon. So this is first carbon, this is second carbon, this is third carbon, this is fourth carbon, this is fifth carbon. So I mentioned the word 1, 2, 3, 4, 5. These all figures I mentioned here because this CH3 group is attached to nearby this carbon. Attached to this carbon is near to this, and it is far away from it. It is called as lowest sum rule. I don't know. This you are going to learn in the next class. This is, this CH3 is near to this group, this carbon, so it is called as 2-methyl carbon. Methyl 1, 2, 3, 4, 5. 2-methyl, and the number of carbons in the parent chain. Number of carbons in the parent chain are 5. That is, it is called parent chain. It is now, this CH3 is called as functional group. So 1, 2, 3, 4 are 5. 1, 2, 3, 4, 5. 5 are at the parent chain. So it is called as pentane. 2-methyl pentane. 2-methyl pentane. Yes, this is there about the three structures. The first structure is a normal hexane. Second is 3-methyl pentane. Third is 2-methyl pentane. First, I made it this CH3 at the center, so it is called as 3-methyl pentane. Now here I made the position of carbon at the second part of carbon, so it is called as 2-methyl pentane. Now we have got three structures. Two more structures are remained. What are those? Just will learn it. I have this main carbon. I'll show two more carbons here. Isomers, we are discussing about the hexane. C6H14. Already just now I read the first structure, second and third structure are available. Now I'll go for the fourth and fifth structure. Number of carbons are 6 once here. One, two, one, two, three, four. I'll show only four now. Four main parent. This is parent child. Two are functional groups now. Two will come here now. One is here, one is here. Yes, two are functional groups. That is, these four are considered as parent child, and these two are considered as branch child. Yes, you can count 1, 2, 3, 4 also parent, these two also branch. No problem. Now, number of carbons are 4 in the parent child. With this carbon, everywhere bonds. Okay, I'll show the hydrogens. No, okay. This is here, and which is the functional group? We'll consider one in this, one is this. Which is the first carbon if I count, because this attached group, or this attached group, one to second group here is there, third also here, four. One for second also is there, for third also is there. From whichever angle we are connecting, both are considered as second and third, second and third methyl group, second and third methyl group. So first is second, whichever it may be. If I consider as here also one, two, three, four. If I count from this side also, it becomes same number only. So what I have to do, at the second portion also we are having a functional group. At the third portion also we are having a functional group. So what to do now? 2 comma 3, 2 comma 3 dash methyl. How many methyl are here? In this chemical we are having two methyl are there, so it is called as dimethyl. Dimethyl. In this group, we are having second place position. We are having one methyl group. Third position, we are having one methyl group. So we are 2 comma 3 dash. We are having two methyl, so it is called as dimethyl. Parent child, how many carbons are there? One, two, three, four. Parent child, we are having four carbons. 4 carbon main changes, it is butane. Main carbon 4 means the word root, the root. This word root number of carbon are 4, automatically it becomes a butane, because all are having single bond. All are having single bond, so it is butane. 2,3 dimethyl butane. It is the fourth structure of the chemical. First was hexane, second was 3-methylpentane, third was 2-methylpentane. Now the fourth one is 2,3 dimethylbutane. The last one is there one more that will complete it, because this question was asked twice in the board examination, and they are asking recently around 3 or 4 years back and 2 years back. Once again they asked this question in the different, because we are having various CBSE boards, the different CBSE boards question paper. This question is there once in the Chennai region, once in the central region. So only this question is most important. So we have to go for it. Now, the last structure of hexane. Number of carbon, once again we are having 6. Now I'll see it. 1, 2, 3, 4. 4 are main carbons, and once again 2 are branches. 5, 6. See here, I showed here only, because both the sides is already over. Now it is only one more is remained. Okay. Now remaining all are hydrogen. Yes, and the branches are in this point for the second, because these branches are identified. The one first branch and one more branch. These branches are identified with this second carbon, because this carbon is near to this carbon. It is not near to this carbon, because this is first carbon, second carbon, third carbon, and fourth carbon. S, and these two carbons, these functional groups are at the portion of second carbon only. Both are second carbon only. So it is called as 2 comma. This first I take this 2. This is 2 comma. This is also at 2. 2 comma 2 dash. We are having two methyl groups. So it is dimethyl, dimethyl, dimethyl. We are having one, two, three, four. Four main carbons are there. So it is dimethyl butane. Anywhere the number of hydrogens are different. Are they 14 only? I'll count it here. Hydrogens. I'll underline only. Here we first and start here. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 hydrogens. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, everywhere exactly 14 hydrogens are there. So it is the isomer only. The group of structures are different. Structural formula is different. Molecular formula is same. So it is about the chain isomer. Chains are there. Even we have got the position isomer here only. We have got the positions of chemicals in this part only. Positional isomer, so we have learned here only because we have shown the positions of these functional groups. We can show for the other chemicals also. We'll go for the positional isomers once again separately. Okay, this is all about the chain isomer. The two structures of butane, three structures of pentane, and five structures of hexane. Yes, positional isomer. Positional. Hardly 2 more minutes time. And so within 2 minutes, I've completed the topic. Positional isomers. Here we are mentioning the position of the chemicals, especially for single bond. There is no use, but with the double bond, triple bond is there. This is most important. For example, butane and butane. Butane and butane, we have got isomer, a chain isomer, butane and isobutane. But here I'll show the structure of two butenes. Structure of two butenes. Yes, two butenes. It is our first carbon. Four carbons are there. Butene means yes, one, two, butene. Butene means we are having a double bond compulsory. Butene. Then one more butene. One, two, three, four. One more butene is here. Four are there. Once again, yes, one. But here I have shown the double bond at this carbon for the right side carbon. After right side carbon, I show the double bond. Here I'll show the double bond at the center. This is the positions actually. Position of double bond has been changed. Position of double bond has been changed automatically. There is a change here. Position of double bond. Here it is double bond after the first carbon because this double bond is there after this carbon, so it is called as first carbon. This carbon is called as first carbon, second carbon, third carbon, fourth carbon. But here the double bond portion is at the second carbon. 1 2 3 4, 1 2 3 4. In this side you can take it. Double bond portion is here only. So this is called as, usually you know about it, butene. But but after which portion the double bond is there? After the first portion of carbon. But 1, it is in. But 1 in. Number of carbon are 4. But double bond of this double bond is there after the first carbon 1, and we are having double bond is available in but in, but position we are mentioning it here, positional isomer. Positional isomer or positional isomer. Here what we are mentioning, number of, once again number of carbons are 4. But because we don't have any branches here, but double bond portion is at after the second carbon. If you count 1 2 3 4 or 1 2 3 4, after second carbon only we are having double bond. Second, but 2 double bond is there, so it is ena. But 2 in, but 1 in, position is mentioning. Okay students, I will end up the topic today here only. In the next class, I'm going to discuss about the last one, that is functional isomer. Then we'll go with the degrees of carbon compounds. Later on, nomenclature of carbon compounds. Thank you, one and all.